Well, hi, everybody. Thank you so much for having me today and for this pilot funding, which has been wonderful. We've done some really cool things this year. I'm excited to tell you about them. I'll start with just a disclaimer, though. I am here instead of the PIs of this pilot project, who are Julia Rager, who is in the School of Public Health here at UNC Chapel Hill. And my graduate student, Amanda Wiley, has really done most of the hard work on this. Unfortunately, neither of them were able to be here today, so I'm presenting for them. I'm the PI of the NIH R01 that has the sample and the data that we're using for this study. So I'm familiar with it, but I apologize in advance for any mispronunciations. I am a developmental psychologist, so this is a little bit out of my expertise, but hopefully I can do a good job summarizing what they've been working on. The study that we are using is called the Brain and Early Experiences Study. This is, as I mentioned, an NIH R01, where it's a longitudinal cohort. We're looking at environmental and biopsychosocial predictors of child outcomes. We have a sample of 203 families in this larger study, and we're following them from pregnancy through age 3. We collect data on lots of things across this time period, including psychological and social stressors and buffers, as well as environmental exposures, caregiving, so parent-child relationships, as well as assessments of cognitive, social, emotional, behavioral, motor, and other developmental outcomes from infancy through early childhood. So we're doing this kind of independent of our pilot study here. So I'll quickly talk through our assessments, but you'll see in the highlighted in yellow areas are the focus of this study that I'll be talking about. But we have data from the prenatal period. We see moms in the 2nd or 3rd trimester, and we're collecting questionnaires from her, as well as cognitive assessments, and then a lot of biomarkers of saliva, hair, urine, stool samples, and blood. We do a visit at 2 weeks of age. We do a brain MRI of baby at 2 weeks. We see them again at 6 months, 18 months, 30 months, and 36 months. And in each of those time periods, we do a lot of assessments. We do MRIs again at 30 months of age. So we have a lot of things we can look at in relation to the household chemicals that I'll be talking about here. So as I mentioned, highlighted are the silicone wristbands that we're using to collect household chemical exposure. We've been doing that for a while at the 6 and 18-month visit, and the pilot funding from HHEAR has helped us to analyze those data. We have now decided to collect further bracelets or wristbands at 30 months of age, both for moms, but also from children. So that's kind of a new addition to our study, which we're excited about. So the initial aims of our grant here, first was just to identify the levels and variabilities of household chemicals that are associated with child neurologic function. For example, phthalates, flame retardants, OPEs, and pesticides that are detected in these silicone wristbands that moms wear for 1 week at a time at 6 and 18 months. Our second aim was just to use the information that we gathered from the first to make decisions about future assessments. So if we saw that we were able to detect these chemicals from the wristbands, we plan to collect more of them and also try them out on the children. And I can say that we did find this. I'll talk about that next. And so we're moving forward with our aim to collect more at 30 months. And then third, of course, is to look at how these early household chemical exposure predicts infant and child neurodevelopment, cognitive and social emotional functioning, and also include tests for interactions. So with things like child sex and other contextual factors. Okay, a quick few words about our methods. So we get our silicone wristbands. First, we take them to Rebecca Fry's lab at UNC, who cleans and packages them, gets rid of existing sediment. We wrap them in clean aluminum foil before and after use and in plastic bags. We either mail them to our families or give them to them in person, depending on the visit. And then once they're returned, they're stored in -20-degree freezers until they go to Duke to the Stapleton lab to be analyzed. They are, as I mentioned, worn for 7 days and nights. We've done this on a subset. So our sample is 203, but we're starting here with just a subsample to see how things go. So we looked at 97 of the wristbands at 6 months and 38 at 18 months. Mothers had a diary that they kept for us each day to tell us how long they wore them for, where they were that day. those sorts of things. We picked our subset for various reasons. One, we were looking at some of our higher risk families, so minoritized race groups, those who are low income, and those who complied. So whether they filled out the diary or not, if they wore them for close to 7 days as a starting point. And we also wanted there to be some overlap with the 6 and 18 months so we could see whether there was stability and consistency across time. Here are demographics. I'll just highlight that on average, moms wore the wristbands for close to 7 days. We had about 30% living in poverty and about 22% who are African-American in this subsample. Okay, so some quick descriptive results so far, and we are still in the midst of analyzing our data. So these are kind of early findings. But we looked at many different chemical classes, but the ones that I'll talk about here today are these 3 that are bolded, which are BDEs, OPFRs, and phthalates. Starting with BDEs, we looked at about 10 of them, and you'll see at 6 months that 3 of them, which are BDE 47, 99, and 209, were detected in at least 70% of the wristbands that our moms wore. Another 3, 100, 153, and 154 were detected in 20 to 7% of our sample. And then finally, 3 were detected in 10 to 20%. And then only 1 was detected in no samples at all. At 18 months, we ran the same analyses and found a very similar pattern. So this correlation table below shows you that there is significant correlation between 6 and 18 months exposure. So there is some consistency and stability that we're seeing. We chose this as one of the chemicals we were interested in because of prior associations in the literature from a study from the World Trade Center cohort. There are definitely many associations with BDE 47, 99, and 100 between ages 1 to 4 on poor cognitive outcomes, IQ, psychomotor. So there's good evidence that this matters for neurodevelopment. Similarly, in the home cohort, findings all the way out to age 8 that are both related to poor cognitive outcomes, but also externalizing behavior problems. So this is something that we're really interested in looking at more closely. We found that there were lower exposure to some of these for groups where their moms had higher education, if they gave birth to their first child at a higher age. And we saw that there was more exposure for moms who were more depressed or had higher race-related stress. So there's likely other things going on that put these moms at risk that we're also going to be looking into more closely. Okay, so for our others, there's similar patterns. I'll go through this pretty quickly since I know we don't have a lot of time, but for our OPFRs that we looked at about 19 of these, we found that for 12 of them, it was detected in 85 to 100% of our wristbands. 4 of them were in 30 to 85%, and only 3 were in fewer than 10%. Similarly, we found this at 18 months. There were multiple that were significantly associated between 6 and 18 months of age. So again, consistency and stability. Similar patterns that we found less exposure for moms who were a little bit older when they gave birth and had higher income. And then there was more exposure for those who were on public assistance, who are minoritized race and higher stress, race-related stress. Finally, for our phthalates, we looked at 10 and found that 7 were detected in 100% of our wristbands. 1 was detected in 92% and 2 were in fewer than 10%. Same idea, we saw this again at 18 months, significant correlations across time. So the patterns are quite clear. Again, we were interested in phthalates because of prior evidence that this matters for neurodevelopment. There's a bunch of examples here that I won't go through all of, but again, through age 9 years of age, there are associations with poorer social cognition, awareness, and communication, as well as more problems with behavior, such as conduct problems, externalizing, aggression, and executive functioning from 4 to 9 years of age. So there's a lot of reason to think that, that this does matter. And we wanted to take a closer look with all of the data that we have available about who it matters for and whether there are main effects or interactions. So that's where we are with kind of the descriptive initial data. We're still collecting data, so we'll be analyzing this more over the next few months. But for now, I'll go to aim 2. This is the one where we wanted to look at whether it was feasible to have children wear these wristbands as well. We've been giving them out to our 30-month children and their moms. We have them wearing one on the ankle and one on the wrist. This is of interest because we think it's possible that the one on the wrist will pick up different things than the ankle. So if we're finding some of these chemicals in toys or food or cosmetics, it may be closer. It might be picked up by the wrist, and that's also closer to the mouth for ingestion versus those on the ankle. And we also were curious if children would be willing to wear these wristbands. Will they keep them on? Will they take them off? Are they uncomfortable? So this is somewhat of a feasibility study, but also to see which chemicals are being picked up across the two. This is the diary that we give moms to fill out each day. We ask about whether they wore the wristband, for how long, at what times, did they wear long sleeves or long pants, where were they? So as kids get older, they're not with their family as much. So at the beginning, in the first couple of years of life, we think that mom's exposure is probably quite similar to baby. But as baby starts to grow up and go to daycare or preschool or kindergarten or spend more time at other people's homes, things may look quite different. So we want to know where they are that week. And whether or not they were willing to wear the wristbands. Were they very willing? Not at all? And does that differ day and night? So again, this is feasibility. We're collecting these now, so I don't yet have the results of this, but we will in the next few months, we hope. Finally, our third aim was to actually start looking at early exposure to these chemicals as predictors of later outcomes. We are right in the midst of collecting our 30 and 36-month data, so the samples are small. But what we can say is that we are seeing some initial associations. So exposure to more BDEs at 6 months is already predicting lower behavioral inhibition at 18 months, which is a precursor of later anxiety and also externalizing behaviors. We're seeing this at 30 months as well. And this is with questionnaire data, but we're also doing these as observations. So we'll be able to speak more to kind of objective measurement of some of these behavioral issues also in the coming months. Similarly, we looked at early phthalates predicting later child outcomes and found similar things. And this was after adjusting for both of these were maternal age, education, gestational age, and child sex. And we're finding associations with TOTM and peer interactions and behavioral inhibition, as well as poor finer motor skills, language development. So there's a whole range. And again, as we continue to collect our data, we'll be able to look at more and with larger sample sizes with more power. So we'll be able to really look at some of those soon. What we'll also like to do next is look beyond main effects and look at interactions. So we know that the chemical exposure alone may not be the driving force. It may be interactions with other stressors in the child's life. So if there are other things going on like poor nutrition or poor sleep or low social support, living in poverty, those together with these exposures to household chemicals might be exacerbating these problems. My graduate student, Amanda Wiley, presented a poster recently on this at SPUR, where she did look at some of these interactions that I mentioned. Won't go through all of that, but just to say the take-home message here was that indeed she found that the effects of TOTM on toddler language development was moderated by maternal experiences of racism. So the presence of the negative effect was really conditional upon that social stress. So it wasn't TOTM alone, but it was in conjunction with social stress. Coming up at 30 months, at the clock, 30 months, we're doing another MRI. We're in the middle of this now, of children's brains. So beyond looking at executive functioning and cognitive assessments, we're going to actually be able to look at brain changes and development over time. So we'll be doing resting state, functional connectivity, DTI, SMRI. That will be at 30 months, as well as other cognitive assessments. And at 36 months, a whole bunch more language, behavior, and health outcomes as well. So we're really looking forward to using the data that we've been able to gather using these pilot funds to look at these outcomes. So that is all. And I just want to say again that Julia and Amanda really did this work, and it's really impressive. If there are questions that I can't answer, please, I know they're happy to take emails. Here are their email addresses. Thanks again. We're happy to have this funding, and we've appreciated it.